Hi, welcome back to the shop. My name's Everett. This time we have a few interesting things on the go. I got a few new tools in. I did a little bit more work on the shaper, but not by much, just a bit more disassembly. I also did a little bit of lathe work for a buddy of mine. He's into downhill mountain biking, and he needed a couple small custom parts made for his mountain bike, so hope you find it interesting. While I don't normally do mail calls and talking about stuff I got in the, ordered from wherever, every now and then, if something really interesting comes along, I will. This is a bolt off of the shaper. Now, looking at the head, whatever, no big deal. It's not a 9/16, nor is it a 5/8. Being a Whitworth, the British, over the last, whatever it was, 180 years or whatever that the Whitworth system has been used, they had their own system of wrenches for these bolts. And for those of you who've never had to deal with Whitworth, they go by the shank size, not by across the flats. So that's where that and that come in. I got on Amazon and had to order some Whitworth tools out of England. So for anybody who's interested in or needing, English tools, or, well, I think these are Chinese, but anybody who needs Whitworth tooling or whatever, yeah, I went to one's place, and also there you go. 5/16 Whitworth fits on there. Now, theoretically, this should be a 3/8 Whitworth. However, because it's a 3/8 head. However, I was then doing some reading and found out that just after during the Second World War, the War Department, or whatever it was called in England at the time, decided in order to save steel, they would shrink the bolt heads by one standard size on the Whitworth system. So that makes this, instead of a 3/8 Whitworth wrench, it's a 5/16 Whitworth standard, like the original standard fits on it. So anyway, I had to get a set of wrenches. I got one set of sockets. There you go, 5/16 Whitworth. And so I managed to get the shaper mostly apart using conventional tools that I have here between metric and the inch sizes that I have. I was just very careful, tried not to round any bolts off or anything like that. The thing is, it's very hard to find Whitworth fasteners around here, and every one of these that I mess up, I have to make. I've got a 55-degree set of inserts coming for my threading tool. I've also got a set of taps and dies coming in Whitworth. They're still coming in the mail, but like I say, I can't just go down to the hardware store, and pick up a bolt for this thing. I want to keep it as original as possible, so if I have to, I'll take a grade 8 bolt with a long shank or whatever, change the head size or do whatever I need to do, or just take a chunk of 4140 and make a bolt if I have to. So anyway, I thought that was interesting as I tore this apart. So the fun with dealing with British threads, especially post-war British threads. So yeah, that was what I got in the mail this week. It's hopefully I can get this thing back together without messing up fasteners now. One thing I found interesting as I was disassembling this machine, and you all might find interesting too, is this switch that used to operate the thing. I mean, there you go, British Klockner. Klockner, that sounds like a German name. Anyway, the center portion here is ceramic frame. These copper bars. What happens is when you flip it, that's off. When you flip it on, the copper contacts short between those bars on the sides. This is completely open to the inside housing of the shaper, like the base. And the operator would have to get in there occasionally to switch the belts from one pulley to another just to change the speeds. This is wide open, so I have, and plus the sparking actions and such, something tells me that this wouldn't really fly with today's electrical code, but at the time I guess it was pretty much standard. But I thought that was amusing and interesting. I'm not going to use the original switch. I'm still going to clean it up and install it just for you know, the looks and such, but I'm going to use newer switch gear. This thing's going to be at least to electrical code by the time I'm done with it. So I thought you'd find that interesting. So one other thing that I didn't disassemble yet, partly because I didn't have the right tools and such, is the cross slide and up and down mechanism for the table. Now the table bolts on to this side here, up this face here. This is the portion that rides on the vertical ways of the machine. These are the horizontal traveling ways. I did manage to get it loosened up enough, and once I got the lead screw moving and out of its little pocket in the machine, in the main housing, I just used a left-handed Saskatchewan socket set to loosen off the bolts holding the retaining, I guess they'd be almost like a gib, the retainers, and that allowed me to slide this up and off the machine. Again, you know, more Whitworth bolts. They're all going to get cleaned up. Grab my tools. Now I'm going to strip it down. I'm just going to strip this down enough to clean up any rust I find and to get the paint off of it. So for the lead screw for the vertical axis, I'm just going to unscrew it. I see no real point in removing it from the, I see no point in removing the gear here from the housing. It's fine where it is. Alright, so that looks like a pin, almost like a taper pin, holding that shaft in, because that's a little gear up here. So which side is smaller? That looks smaller to me. Yeah, there we go. She started. Yeah, there we go. There's our taper pin. And this should slide that gear off. Now, ensuring I'm using the proper tool for the job. Ah, I see. Because it's hitting a shoulder inside there. Ah, there we go. Yeah. Just had to pull the shaft back. I wasn't sure if there was another locking mechanism in there. So there's the one 90-degree helical gear. Definitely some wear on there. I think it may have been not lubricated sometimes. So I'll have to get that cleaned. I'll get those cleaned up. There's the shaft. Put the taper pin in so I don't lose it. That goes aside. Wonder how far over I can get this. Because I can see, I don't know if you can see them there, you got bolts and nuts holding that in place. Let's slide. Yeah, loosen those off. Loosen off the gib screws on that one. All right. I guess I'll have to spin it off the end. Not a big deal. This is 7/16 Whitworth. That is not 7/16 of an inch. Like I say, I just find it amusing. Because I've only got the one open end wrench, might need the left-handed Saskatchewan socket set, which oddly enough is both metric and imperial, but apparently is Whitworth as well. Has an adjustable spanner that those of you from across the pond would call it. Across the pond from here, that is. Alright. Now, should be able to just take and unscrew this. There we go. All right. We're out. There you go, the bronze nut falls out. Set that little linkage assembly aside. Oh, huh. Check this out. I see more bronze coming through. More pieces that were broken in a former life. All right. There's our slide. Set it aside. And I do believe that is now broken down far enough. Yep. I don't want to sound like I'm really too critical on British Whitworth threads, because it really was the first standardized thread form for a whole nation, right? So, I mean, a lot of really cool stuff was built using Whitworth threads. So this is about as far as I need to take this part to get the paint off of it. What I'll do is I'll just strip the paint like you saw in the previous video, if you saw the previous video, and we'll go from there. This is about as far as I'm going to be able to get for tonight anyway. So, all right, I'm happy with that. I just needed some proper wrenches to do it. So my friend Matt gave me a call the other day and was asking if I could do something up for him. This apparently is a spacer out of his downhill mountain bike. Apparently they have different ways of attaching the front wheels to the forks. I guess they use bigger bearings and stuff like that than your typical mountain bike. This spacer's off of his, but he wants to put a different type of tire on. In order to do that, he needs a special custom adapter like this, only 20 millimeters wide instead of this one here, which I think is somewhere around the neighborhood of 16 or so. He gave me a sketch of the basic dimensions he needs. Didn't really give me much for tolerances, so I'm just going to assume slightly under if necessary, you know, by 0.1 or whatever. But at least he gave me measurements and a drawing of what he's looking for. We'll use this piece 6061 to make it. It won't be anodized like this one because I haven't gotten set up for anodizing yet. One tricky thing with this is because he gave it to me in metric and my machine's in imperial primarily, I mean the dials are graduated with metric and imperial on the cross slide, but I'm not sure how much I trust it in the metric measurements, that's for sure. So we'll see where it goes. There will be a significant amount of light cutting and measuring and seeing how much of a cut's actually been taken off. Yeah, we'll get this made up. Again, it's not that I'm anti-metric, it's just I have to work with the equipment I have. Alrighty, so finally sent a better half off to bed. Little man's asleep. He has been for the last couple hours or so, and now I can finally come play in the shop. We're going to take this piece here and chuck it up and start cutting our little spacers out of it. Now, it's a fairly thick piece. It's aluminum. I'm not too worried about deflections, so I'll give it about that much stick out. I'm going to be cutting both pieces in the same mounting, so what we're going to start with is we'll face this end, drill the center. I'm probably going to go 2 inches deep with the hole, and we'll bore it to size, whatever, and then we'll start doing our outside features and lop them off. that punched it out to 7/16. So now we'll get on to using a 3/4 because we need a 20 millimeter hole. 3/4 is close to 19 millimeter, that'll get us close. It's kind of cool as I finally got some taper shank drill bits for the tailstock. Yeah, it looks like this one needs to be sharpened. All right, there we go. 3/4 inch hole, a couple inches deep. So what we'll do is we'll now bore this out to 20 millimeters. Well, just shy of 19 and a half. Yeah. 2004, 2005. Yeah, so that's the size we want. Perfect. Alright, so we have roughly 37.2. We need to get down to 31.6. Okay, so that's what, 5.62 millimeters to come off. That's got to be pretty close. 31.7. Yeah, we'll call that close enough. Here we go, take that burr off before it gets too far here. Now I just want a witness mark back here so I know, the point of no return. To do that, finally got myself a nice big fat Sharpie. Okay, so this, there you go, that's my 15 millimeter line. 15 divided by 25.4 is 590 thousandths. I'm sorry everybody who loves metric, I don't have a digital readout, and I don't have any other better way of measuring precision measurements in the Z-axis here. So what we'll do is bring up dial indicator, dial in 1 inch, 590, touched and zeroed, touched in more than one way, so 6.3 millimeters. .75. That should be within a tenth. 25.56. At 25 and a half. Up here he's got 26 millimeters. Down here he's got 25.5. I'm going to call that good. Alright, and as far as our depth, we're getting a reading right around 15 millimeters there, so that should be good there. Okay, now that little step needs to be another millimeter off, so 24.5 here for 3 millimeters in. 3 millimeters is 118 thousandths, so we'll set our 0 again, then go to 1 inch 118. Again, my apologies to everybody who's metric. For Z-axis movement in precision, all I have is an imperial gauge, so I have to convert for that one. I don't know if you can see from the camera there, but it's basically the same sort of profile and everything except for about 3 millimeters longer. Now for this groove back here, what I've done is I have removed the usual parting tool I use and instead installed a 5/64 parting blade in the holder. 5/64 is within a couple hundredths of a millimeter, so that will be just fine for making the 2 millimeter groove in our little spacer here. Now the piece needs to be 20 millimeters overall length. There's a 1 millimeter shoulder in the back, so that makes 19. We need to take another millimeter or so because this is 4 millimeters wide here. The groove is 2 millimeters wide, so 18. So if we go 18 millimeters from this end, if I just touch off this tool to this end of the part and go in 18 millimeters, I should be able to plunge and then start taking out my groove there. Now 18 millimeters is approximately 708 thou, 709 thou, somewhere in that neighborhood. There we go, that's touched. So we need 708 thousandths. So for kicks and giggles, let's do 1 inch, 708. Back it off. Bring it up to where it says 1 inch. Actually, that looks just about right there as far as even visually. Yeah, lock you. There we go. A groove here of roughly 29 millimeters. We're at, what, 31.75-ish? So I need to take 2.75 millimeters. See if the screens are not... Whoa, that's, yeah. Okay, we're going too fast. I just took that blade out and gave it a different profile on the nose. Let's see what it does now. .9. Considering the fact an O-ring just sits in there to sort of dampen things, that will work just fine. Now we need to move over another 4 millimeters. What I'll do is I'll part it off to length, and then for this little lip shoulder on the back side, all I'm going to do is I'll just put jaw protectors in the jaws, and I'll just profile that on the back side. So what we need to do is now move the carriage this way 157 thousandths, otherwise known as 4 millimeters. I can hear it's getting close. There we go. So there you go. There's our one piece. I still have to profile the back end of it, but apart from that, we should be pretty much done. I'm going to cut another one of these out of this off camera because you've already seen one made, and then we'll do the back profiles. A little bit of run out. We need to take 6.3 millimeters off the diameter in by 1 millimeter. And 25.4. The outside diameter of that is 25.5. A little bit of deburring, and this part is done. And a quick deburr on the inside of the hole. So there we go. That's the one spacer he wanted. I'm just going to do the same thing to the other one for fixing up this back end, and I'll bring you back in after.
Hello, my name is Matt. I recently ran into a problem that I needed some help with. I had bought this bike right here, and it's got a 20 millimeter axle on it, but it does not have a spacer right here. So the spacer keeps the forks from crushing when you tighten it up. but it also provides a dust cap for the bearings right here. So I did exhaust my sources looking for a part that I could replace it with, but they don't make them, so I needed to make something custom or have something custom made. Boom. So now if you have a look, that axle spacer's in there and it's covering that bearing and sealing against the hub right here. As you see, it spins freely and the wheel is centered exactly how we want it. So pretty pumped that that worked out. Good job, Everett. Some things can be completed even if you don't think they can be, with a little help from your friends. Thanks, Everett.
Hope you all found this somewhat interesting. Thanks for watching. Thanks for subscribing. Thanks to everybody who's sent me not just comments and the below, but I've gotten some really fun emails from people from around the world, and people asking for plans, people sharing the stuff that they've been doing. Honestly, half the fun of this whole thing is connecting with everybody. So for what it's worth, I may not know every one of you by name, but as I've been getting to know some of you, it's been a lot of fun. So thanks, I appreciate it. Otherwise, thanks for watching, thanks for subscribing, and I'll see you all next time.